The 10th problem which we have is a pretty interesting problem. The first part says we have a 20 ml of barium chloride solution requiring 10 ml of 0.4 molar AgNO3 for complete precipitation of silver chloride. We want to find the osmotic pressure of barium chloride assuming complete ionization of barium chloride at 27 degrees Celsius. And in the second part, we are given that at 10 degrees Celsius, the osmotic pressure of a solution is 500 millimeter of mercury. The solution is now diluted to a new volume and the temperature is also raised to 25 degrees Celsius. And it is given that the osmotic pressure has decreased from 500 mm mercury to 105.3 millimeters of mercury. If final volume is Vf and initial volume was Vi, then we need to find the ratio of V final and V initial. So starting with the first problem, for the first part, let us write the equation of precipitation of AgCl first. Barium chloride will react with AgNO3 to form barium nitrate and AgCl will precipitate. Here we can see that 1 mole of barium chloride requires 2 moles of AgNO3 for complete precipitation of AgCl. Hence, if molarity of barium chloride is M, then M into 20 represents the number of millimoles of barium chloride, and these will require 2M into 20 millimoles of AgNO3 for the precipitation. And here we are given the millimoles of AgNO3 to be equal to 0.4 into 10, and hence we got the molarity of barium chloride solution to be equal to 0.1. Now we need to find the osmotic pressure for this barium chloride solution. We have got the molarity, that is the concentration of this barium chloride solution, and we know that the osmotic pressure is equal to ICRT, where I represents the Van 't Hoff factor, C represents the concentration initially, R is the gas constant and T is the temperature. Assuming 100% ionization, we have barium chloride getting converted into barium 2 plus plus 2 chloride negative. If we consider the initial number of moles of barium chloride to be 1, this becomes 1 minus alpha, alpha and 2 alpha. So the final number of moles come out to be equal to 1 plus 2 alpha. And since it is given that we can assume the complete ionization of barium chloride, so alpha will be equal to 1 since there is 100% ionization. So our final number of moles becomes 1 plus 2, that is 3. Initial number of moles were 1. So I is equal to 3 upon 1, that is 3, into the concentration which we found out to be equal to 0.1 into the value of gas constant, that is 0.0821, into the temperature, that is 300. On solving this equation, I will rewrite this equation again. This is ICRT. The I we found out to be equal to 3. Molarity we earlier found out to be equal to 0.1 into gas constant 0.0821 into 300, which is the temperature, and this is equal to 7.38 atmospheres. And hence the osmotic pressure of barium chloride, assuming it to be 100% ionized, is 7.38 atmospheres. For the second part, it is given that at 10 degrees centigrade the osmotic pressure of a solution is 500 mm of mercury. So let us say if the initial concentration was C1 and finally the concentration becomes C2, so pi 1 is equal to C1RT1 and pi 2 is equal to C2RT2. If temperature T2 is 25 degrees Celsius and temperature T1 is 10 degrees Celsius, let us take the ratio pi 1 upon pi 2 is equal to C1T1 upon C2T2. Our initial pressure was 500 divided by the final pressure, which is 105.3, is equal to, let us say the initial concentration is equal to moles upon initial volume, and this is equal to moles upon final volume. The initial temperature was 283 and the final pressure temperature is 298 kelvins. This n and n gets cancelled. We want to find the ratio of V final and V initial, so it is equal to V final by V initial, that is equal to 500 into 298 divided by 105.3 and 283. This on simplification comes out to be equal to 5, and hence our final volume upon the initial volume, the ratio is equal to 5, and this is our final answer for the second part.